Welcome. So we're going to be talking about y-squared transformations now. So let's read this before us. So y-squared transformation stretches out the upper end of the y scale. So the y values are squared and the x values remain the same. Okay, so the larger the y value, the more it moves up. So let's look at a few examples here. So first thing you have to recognize is that we're now looking at our y values here. So the bigger y values are up here. So these are the ones that are being stretched up. These are my smaller y values. So while we're still squaring them, they're not moving up as much because they're smaller numbers. Remember, the larger the value, the more it moves. So too over here, here are my big old y values. So it's these points that are having more of a stretching. And just take note of the shape of these relations. So let's just have a look at these shapes for a moment. So as you can see, this one looks like that. This one looks like this. These are ideal for y-squared transformations. And remember, you can refer to your circle of transformations in your bound reference, that little diagram there, to help you out when identifying what transformations you should be applying. With all that being said, let us now dive into this question here. Okay, it says, example 12, plot the data in the table below. So here is height above sea level in meters and the visual distance from the horizon in kilometers. Now, what is my explanatory and what is my response variable? Well, the height above the sea level is going to be your explanatory variable because the higher you are, the further you can see from the further you can see from horizon. So that's my response variable. So the height you are is going to impact your visual distance from horizon. That's how it works. Okay, let us now plot this information. So I'm going to come to my trusty CAS calculator and I've already populated my spreadsheets page with the relevant information. To now plot it, I'm going to go Control, Add Doc, and I'm going to go Data and Statistics. Then I'm going to come here and my explanatory variable, which is my X, is the height. And then my response variable is the visual. So the visual distance from the horizon. And as you can see, this thing's got a bit of a curve to it. So how are we going to make it more linear? Well, as you read here, what we're going to do is use the y-squared transformation to linearize the data. So y-squared, well, this right here, my response variable is my y, the explanatory variable is my x. So y-squared means I'm going to be taking the visual distance and I'm going to square it. I'm going to take the visual distance and I'm going to square it. When I have a variable which is two words, I put them in brackets and then square it. And that's saying I'm squaring this whole thing. If I just put the squared next to the distance, it just looks like I'm squaring the distance and not the whole thing there. So just be aware of that as well. Okay, so let us perform this transformation. We come back to our CAS and we come here. And now I'm going to come up here. Now remember, I want to square the visual column here. So I'm going to call it visual SQ. And then I'm going to come to this cell here. I'm going to go equal, then I'm going to go variable, then I'm going to go visual, and then I'm going to square it. And that is going to square all of this column here and put it there. Now, if I jump back here and I change my y-axis, because remember we're changing our y, to visual squared, you can see it now becomes more linear. Isn't that amazing? Okay, what is the next part of this question asking me to do? It says, fit a line to the transform data with y squared as the response variable and x as the explanatory variable. Write its equation to the nearest whole number in terms of the variables. So I need to come back here and I need to find my least square regression line. The easiest way to do that when we're here is just to go Menu, Analyze, Regression, and then go Show Linear. And there it is right there. So we need to round it to the nearest whole number. So 33.6 will become 34 and 12.6 will become 13. So let's now write this out nice and neatly for ourselves. It's going to be the visual distance, and remember, put that all in brackets and square it, is equal to 34 plus 13 times, now I'm going to put it all in brackets and write my next variable, which is height above sea level. Whoa, I spelled C wrong. That's not great. Perfect. And that right there is our answer. Let me just tidy it up a bit. So 34 plus 13 times height above sea level. Amazing. Okay. Let's now come here. It says use this equation to predict the distance to the horizon to the nearest whole number when the height above the sea level is 65. So here they're telling us that the height above the sea level is 65. So let's write out our equation here. So it is the visual distance, all of that squared, is equal to 34 plus 13 times, and now I have 65 in my height above sea level, because I know that it's 65, and we're all done there. Now, we have to be careful when answering this, because we've got this squared here, which makes things slightly more complicated. If we come to our trusty CAS, and we come here, and actually let's open up a new page and go calculator. And what I'm going to do is just type in 34 plus 13 times 65. So we come here and we go 34 plus 13 times 65. 34 plus 13 times 65. It's going to be 879. Now, what you need to recognize here is that the visual distance squared is going to be equal to 879. We don't want to find what it is squared. We want to, as it says, predict the distance to the horizon. So we just want the visual distance, not squared. So what are we going to do? Well, to get rid of a square, we're going to square root. So we're going to square root both sides, which means I'm going to be left with a square root of 879. So we could come here and we can go control this, then I'll come up, grab this, square it. Oh, and also remember what you have to do is go control enter, and we're going to get 29.64 is equal to 29.64. Now it says we need to provide it to the nearest whole number. So therefore my answer is going to be 30 kilometers. And that right there, everyone, is our answer. So as you can see there was that extra step of square rooting. Now there is a way to get around that. There is a way to get around it. The way to get around it is to do this, to use your solve function. So go menu, algebra, solve. And then what we can do is go, all right, I've got the visual distance squared. So that's y squared is equal to, and then go 34 plus 13 times 65, and I'm solving it for y. So as you can see, I've included the visual distance here. I've just denoted it with a y, so y squared. And now when I go control enter, it's going to give me both a negative and a positive. Obviously, because we're dealing with distance, we only care about the positive one because only positive distance makes sense, but we still get 29.647. So by using this function right here, it is helpful. So some of you might think, well, I'm a bit worried that I'm not going to remember to square root it. Maybe I should just use the solve function. So what you can write down in your notes, if you like, is just solve y squared is equal to 34 plus 13 times 65, comma, y, just like that. You can do it that way, and that's also going to give you the answer. I think it's important to know both ways. Okay, and now we come to this one right here, this last question here. And there's just a slight little thing I want to change here. Instead of 40 meters, write 40 kilometers. There we go. Use this equation to predict the height above the sea level when the distance is 40 kilometers. So the distance is 40 kilometers. So if we scroll up for a second, so the visual distance from the horizon, we've been told that it's 40 kilometers. So that means it's somewhere between 34 and 50. It's somewhere here, isn't it? This is where 40 kilometers would be, somewhere between these. And you can also see why I changed it to kilometers. I think that just might be a little error in the notes. It should be 40 kilometers. Okay. What we need to find is the height above the sea level when we have a visual distance of 40 kilometers. So let's just come here for a moment. What we're going to do is we're going to take 40 kilometers and put it into our visual distance, because that's what it is. It's the visual distance right there. And then we're going to square it. And that's going to be equal to 34 plus 13 times. Now, we're trying to predict the height above the sea level. So obviously we're not going to sub anything into our height above the sea level thing. That's what we're trying to solve for. Height above sea level. Perfect. Now, what are we going to type into our CAS to get our answer here? Well, what you type in is solve. So we're using that solve function. 40 squared is equal to 34 Oh, that's an ugly, ugly 3. 34 plus 13 times, now instead of writing height above the sea level, let's just say h, and then comma h, because that's what we're solving for. Okay, now we come back to our CAS. If I can grab it. All right, so I'm going to go menu, algebra, solve, and it's going to be 40 squared is equal to 34 plus 13 times h, comma h, just like that. 40, 34 plus, perfect. Oh, and I forgot to hit Control Enter. So it's going to be 120. So the height above sea level is equal to 120.46. Now, the height above sea level was measured in meters. And let's just double check that we've got our units correct here. So height above sea level, which is what we're trying to predict for, is measured in meters. So that should be meters there. And it doesn't mention anything about rounding. Use this equation to predict the height above the sea. Nothing about rounding there. So we can leave it just like that, 120.46 meters. And just like that, everyone, we are done. We have answered everything we need to. Hopefully you feel comfortable with applying your squared transformations, and hopefully you enjoy your homework as well. Make sure to reach out if you have any questions.